Okay. Can everyone hear me all right?
Yep.
Yep.
How you
Okay.
going?
Well, thank you. Well, welcome everyone to our final meeting for the year. Good to have you all along. I'll just get this working. So thank you to all our affiliates and to our industry associations, to our corporate members. And tonight's meeting, we have all valves talking about warm water systems, design and maintenance. We've got Ducks Hot Water giving us some smart insights into hot water. And we've got Haugen running through some trade waste tips and tricks. So committee report. So email since our last meeting. Again, if you're not getting the emails, get in touch with us. You might have unsubscribed to a particular group or you've changed email addresses and haven't updated your details in the system. So Paul Naylor, Master Plumbers CEO, retired last week, I believe it was. And if you do know Paul and you want to get in touch with him, send us an email and we'll pass on his details. CPD session from Stable Ultron, that was on today at lunchtime. So the value of decentralized hot water systems. The NCC 2022, so we've been advised that's been delayed by around about 6 months. So that's proposed for adoption on the 1st of September 2022, and like most things, COVID's been the reason given for its delay. We had our general meeting invite. We had a CPD session from Victolic a couple of weeks ago on HCAA alternative joining to welding. Standards Australia issued AS/NZS 5601.1 2013 Amendment 4 and AS/NZS 5601.2 2020. Standards Australia draft out for comment, 2118.2 automatic fire sprinkler systems. So with any of the standards, I think most people know by now, but you can either send your comments to admin and we'll submit the comments on your behalf, or you can click the link and register and submit the comments yourself. We had a CPD session from CUDA Group on safeguard systems for hydrostatic testing. We had a couple of new performance solutions, which we did discuss at the last meeting, but Plastech have prepared one on reactive soils that's now listed on our website, and then Ream and All Valves also have one on warm water systems, but for their ones, you'll need to contact them with your specific project details and they'll help prepare those on your behalf. Fair Trading released a certified practice standard. We had All Valves do a really good presentation on balancing valve selection. We did also have some spam emails circulating around to a fair few people, which were pretending to be from education at HCAA. So yeah, like always, just be careful when you get an email to make sure it's actually from who it says it's from before you click any links or attachments. And then we had another CPD session from Kembler on press fit systems. So for next year, I think we're booked until early February, but they're only the next 3 I've listed up here. But if you're keen to do a CPD session for us, we're averaging between probably 40 and 70 people booking per CPD session. So yeah, as per the screen here, it's fortnightly, run from 12 till 1. And the next one coming up is from ACO on trade waste. Then we've got one from the South Australian government on interactive water features, and then from Kembler on stainless steel piping. But yeah, if you want to present, send through your details to admin@hcaa.org.au and we'll book you in. And these talks are also listed on the website if you if you want to see what's coming up. Otherwise, you'll get the regular emails telling you. So the diploma has been delayed to term 2 next year from term 1, with again coronavirus being the cause for that. So we do have, I think, over 70 students booked to start the diploma. That's right, Rod?
Yeah.
Yep.
There will be a small group that start. They've got a little bit left to do from their Cert 4 training. That's the guys that currently have a license. They'll be starting in term 1. Fingers crossed.
Yep.
That's the plan, and then they'll kick into the diploma term 2.
Okay.
And then there's a whole bunch that'll start a new Cert 4 from scratch after that.
And then I think I saw Rod Jackson in here. Do you have anything to add, Rod? From TAFE's perspective, or?
No, we may have another slight delay. We've just had another restructure announced last Thursday, which has really thrown a cat in amongst the pigeons, but we'll keep you informed.
Okay. No worries. So, yeah, I guess we'll give an update on that at the next meeting, which will be March next year. So until then, we'll just hope that it kicks off in term 2. Thanks, Rod and Rod. So yeah, Standards Australia, there's no documents currently out for comment. The latest one was that Drencher code that I mentioned earlier. ABCB, so they've just launched this new handbook on warm water systems, which is quite relevant to tonight's topic. I did see Tom Roberts is here. So did you want to throw in anything else here on this particular new book here, Tom? Can't hear me? Maybe he's not listening. ABCB plumbing team. It's all right if he's not there. So HCAA did contribute to this book in some capacity, but yeah, if you want to, you can log onto their website and download a free copy of that, this handbook. And there'll also be emails going around. The ABCB will be forwarding some correspondence, I think, through LinkedIn and via email, but we'll send people copies. But if you want a copy now, you can just go to their website and download it for free. And it's quite extensive, so a lot of effort's gone into it. So the ABCB also have their watermark campaign. So yeah, don't forget to check for watermark when you're doing your site inspections, and help the ABCB and Fair Trading to enforce the watermark. Okay, so I only got a couple of photos this week. I can't actually remember who they're from. So normally I get a whole bunch of photos, but
What was mine, Nick? Sorry.
Oh, what was yours? Sorry.
on the right hand side.
This beautiful one here, and then and this one was actually from Sydney Water. So yeah, it's just a greaser ester with a dodgy lid on it. So keep your eye out for those. And where was your one, Rob? Was yours a truck depot or something, or a service station, or? No, gone. Yeah, so we've had a pretty quick run through tonight. I don't think I have anything else to comment on tonight. So what time is it? 6:40. Yeah.
Before we get into the other stuff, just got a quick question. We're having a chat today about people still trying to get their hydraulic certification or registered certifier approved through Department of Fair Trading. Just curious if anyone here tonight is still waiting to get that approved through Fair Trading. If you can let us know or send us an email to myself at theeducation@hcaa.org.au, or to Nick. Yeah, just keen to see if there's many people still waiting, because they had advised us that they were going to get all those through and approved as quickly as possible. But I know of a couple of people still waiting. So,
can I ask a question? It's James Allen here.
Yeah.
With regarding that fair trading approval, who are the members in the HCAA applied for that approval, and what were the minimum qualifications they had to apply?
So I think the minimum requires your hydraulic diploma. I think there's been a number of us that have applied so far.
Yeah, I'd say there's about
10.
No, there was more than that. There was 2 2025, I'd say people contacted us who, because the fair trading was supposed to process all of the applications in 8 weeks, and they were taking up to 9 months. I think one person had been waiting a year for theirs to be processed. So I think there was about 20 names on the list I had. Fair trading approved about 12, and there was 8 that they rejected that had to provide more information. It is quite a thorough process. You have to provide about an 80-page CV with lists of projects you've worked on. You have to have a certified copy of your diploma. You have to do the 4-day course with the UTS, which is about $3,500. You do 2 days 1 month, and then 2 days a couple of months later, and then you have to do a series of assignments, submit those, and then once you get the certificate from UTS, you have to send that certificate in with your application. So all up, if you want to get on that register, because that will be enforced July next year for Class 2 dwellings, you'll have to have that qualification to sign off. And that process, best case scenario would be 6 months, but it's more likely 9 to 12 months to get accredited because of all the hoops that you have to jump through. So it is quite a long process.
But the minimum requirement was the diploma, was it?
Yeah, the minimum requirement's a diploma. There's 2 pathways. One is the diploma, and one is a degree. Yeah.
Yep. Thank you.
Okay. No one else. And then if anyone is applying, I do have a template that will probably save you about 2 days of work that I can provide you with if you email me. So you still have a fair bit of effort you have to do yourself, but it will save you a lot of time. So just contact me if you need assistance with that. All right, Dan Dillenbeck, are you right to start if we kick yours off early, or?
If you'd like to, no worries.
Okay. Okay, you can steal my screen now, I think.
Yeah, no worries, mate. All right. Well, we're looking forward to presenting this to you guys tonight. So thanks for joining. As you guys are probably aware, All Valve Industries has been a long-time supplier of thermostatic mixing valves in the market. But probably about 5 years ago, we did launch a warm water system that has been New South Wales Health approved under Apricus Australia as the APT range and been fairly successful. So I just want to go through some of the key sort of design and maintenance aspects of this product in the market. But before we sort of go into that, I thought I'd sort of just show where we can install these products. So if we looked at the definition of a warm water system at the sort of highest level, the Public Health Act defines it as a system designed to heat and deliver water at a temperature of less than 60 degrees C. So that trying to comply with 45 to 50 degrees C as per the code, at least when you reticulate, you should be looking at a deemed to satisfy provision if possible. However, as it notes here under the PCA, there is no deemed to satisfy provisions for warm water. So that really only leaves us with one option, which is a performance-based solution to meet the compliance of the performance requirements. Now, to write a performance solution, as Nick Soden mentioned, the ABCB has written a very good guide as to what aspects should be looked at. So taking into consideration some of those key points like water risk analysis, the maintenance and treatment of warm water systems and monitoring of them, we've come up with a performance solution template that can be used and applied to your projects if need be. So our Tempomate unit, we assemble, engineer and test that here locally in Sydney. Excuse me, we use the Cleffi 25mm thermostatic mixing valves as part of the assembly, and they can then be used for 45 to 50 degrees C applications. We do provide a 5-year warranty on manufacturer defects on that unit as well. Now, the Templemate system, some of the sort of key features that we sort of showcase for it, we've got an inbuilt thermal disinfection bypass, which is key locked, which can quickly thermally disinfect the system if need be. We've got pressure and test points and gauges on virtually all incoming and outgoing pipework, as well as a return pipework, so you can quickly gauge what's happening in the system. We have a test tap on the outlet of each TMB, and that allows us to perform tests such as thermal shutdown tests without interrupting the water supply. So we can drain that off to a bucket and just make sure those TMBs are working, and by isolating them out of the system. We use all 316 grade stainless or copper pipes, and there's no electrical components within the warm water system itself. And because we just use normal TMBs, these can be installed, commissioned and maintained by suitably qualified plumbers. Now, if they don't want to do that, we can assist with commissioning and maintenance through a service contract. In terms of the installation, the cold feed to the unit, can be no check valves on this line. And the reason being that not only does it feed the cold water to the unit, but when there's no draw off, then that line is also used to return water from the building return back to the water heater as well. That cold supply also needs to be common to the water heater system as well. The check valve must be installed directly after the cold water feed from the warm water system. And if you do have a hot water return as well, that needs to be installed after that check valve. Now, in general, we do suggest that we use a buffer tank, which assists with reducing the pressure and temperature fluctuations. But as I'll show later on, we can also use a tankless system as well. It's also no problem to manifold them if you want to get higher flow rates. And if you do want to do a direct connection to a tank pack, for example, then we just need to be careful in selecting the right type of continuous flow hot water heaters. They do need to be able to modulate the heat output quite accurately to varying flow rates, so we provide stable temperatures. So we have had quite a few projects with ducts, for example. I know that they've got some advanced technology in their heaters, which can both modulate the heat output very accurately, as well as provide some load sharing between the units to reduce the pressure losses. So we're quite comfortable in pairing up our ducts, the duct system with the Templemate system. Now, if you do have a project you want to discuss with us, some of the key features or things we'll be asking you is obviously what sort of facility is it? You know, based on that facility, we'll take into consideration the peak flow calculation, of course, the set temperature, etc. What's the recirculation flow rate? We need to first account for roughly a 2 to 3 degree temperature loss across the circuit. And if it's an existing building, can the return lines and the pump handle that return flow rate that's required? For disinfection, there's a number of considerations here. For example, what's the quality of the water like? Is the customer aware of what maintenance is required with that disinfection system? And is there any existing Legionella that we need to take into consideration when looking at what disinfection technology is available? In terms of commissioning and servicing, and this is a key part of any warm water system, is that we need to make sure that the client or the end user has the ability and knowledge to maintain that system. If they don't, then either we can't sell it to them or we need to provide some sort of service contract with it. So we have 4 models within the Templemate range. The APT 80, 160, 240, 320, which refers to a 1, 2, 3 or 4 valve system. And the 80, 160, etc. refers to the rated flow of the unit. Now, that's not to say what we designed to, but just as a quick reference, if you want to work on, say, 50 kPa loss at 1.2 meters per second, then we can work in lots of 35 liters per minute. Or if you have a system that can tolerate a little bit higher velocity, say stainless steel or something else, then we can increase the flow rate a little bit as well. We're certainly happy to help you size up the warm water system though. We use both AS3500 as well as cross-referencing DIN 1988-300 to provide a system that would be suitable for that application. So a couple of pros and cons of going warm water. I know, I mean, Allvalve has traditionally been a TMV based supplier, but there's been a lot of demand and requests for warm water. So of course we put together this package. But especially in saving costs, of course, through reduced installation and maintenance of that system compared to TMVs. We're also reducing energy use because when circulating warm water instead of hot water, there's less heat loss through the pipes. And it's a lot easier to maintain a centralized system. We can certainly schedule the maintenance a lot easier without interrupting water supply or having to go into rooms, for example, to maintain the TMVs. But of course, a warm water system does potentially provide a higher risk for Legionella. So it is the responsibility of the facility owner to maintain that water health. And as mentioned, if they're unable to do so, then they need to subcontract that out. Now with warm water, obviously we're heating or we're tempering it centrally and circulating and delivering at 45 to 50 C. And we're comparing that to something like a hot water system. At some point where the TMVs are installed, there's the cold water supply, which can introduce Legionella potentially. So TMV systems are still considered a risk for Legionella. If we see the hot water system or hot water as disinfectant, then the TMV breaks that residual. So even though you have a TMV-based system, you should still disinfect the lines downstream of that in the dead legs, which is why the likes of Calefi have introduced things like thermal override on their valves, because it's still a maintenance procedure that should be done. So disinfection technology, which we can supply with our warm water system. Now there's obviously two types, one being focal, where we are just disinfecting a portion of the water, usually the incoming or at the outlets, for example, UV, ozonation or filtration. And then you've got systemic types, which disinfect the entire system, especially areas like stagnant or distal areas. And by that, we're referring to things like thermal disinfection, chloramine, or copper silver ionization. Inbuilt into the unit, as I mentioned, is thermal disinfection. That key lock bypass, if you open that up and close the cold water inlet, that will allow hot water to both sides of the TMV, which the TMV can't shut that down. So it will allow hot water through the cold water side and provide hot water throughout the entire system. Of course, if doing this, you need to tag out your fixtures, and sometimes this might not be feasible in a large site, but it's certainly something that can be done as a decontamination method with every unit that we offer. I guess what we call our standard offer is UV disinfection. It is effective as a focal source of disinfection, but it doesn't provide any residual. So for that reason, we do recommend that the UV is used in conjunction with something else like thermal disinfection as an overall disinfection strategy. UV systems will require usually quarterly to 6 monthly servicing, and usually every year you'll require to service or replace the lamp, sorry. Another system which we like to offer as an alternative is copper silver ionization. We feel that it's a superior product in the market. It provides residual throughout the entire system. The copper silver will break down the biofilm in the pipework. It's not corrosive. It doesn't affect the taste or smell when dosed correctly, and it can be quite easily retrofitted into existing buildings. If you look at EN Health guidelines, there's a lot of considerations with use for copper silver. For example, it requires expertise, and we've partnered up with a company called Bion Water in Queensland, who has something like 20 years experience in copper silver, Legionella control and water risk management, and have had a number of very successful sites throughout Australia. It's also important to dose the copper silver correctly. There's some systems that just do it on a time basis, but with this Bion Water system, they dose it with an ultrasonic flow meter. So they proportionally dose every part of the water correctly to the requirements of the Australian Drinking Water Guidelines. Now, copper silver will require maintenance, generally quarterly, because the electrodes can scale up. And finally, the ability to disinfect with copper silver is dependent on pH, but generally speaking, it's not an issue for potable water. So this is an interesting chart provided to me from Bio and Water. This is a rural Victorian hospital, which remains anonymous, of course, which had a number of Legionella accounts within their fixtures. Back in 2011, they installed a copper silver ionization unit to treat the entire hospital. And from that point, it virtually eradicated all Legionella counts. You will notice a few excursions down the track, but what that is attributed to is the breakdown of the biofilm, which gets released and then finally gets caught in the fixtures. So once that sort of gets cleaned out, then the Legionella virtually disappears. And that is all. Thank you very much.
Thanks, Dan. Does anyone have any questions? I'll just check if anyone's chat. Nope, nothing in the chat yet. If I throw a question out there, Dan, how many systems do you think you've sold over the past 4 or 5 years?
Probably 30-ish, maybe a bit more.
Mm-hmm. And do you guys, you mentioned maintenance sort of implied that you guys offer that. So is it, you can, if a facility wants to outsource the maintenance, you guys do offer that as a service?
Yes, we can. I mean, at this stage, no one's taken us up on the offer. I guess our theory is that we want to give as much back to the plumber as possible. That servicing these warm water systems isn't rocket science. As long as it's done properly, then anyone with a TMV certificate should be able to do so. And what we wanted to do as part of, before we hand over, of course, is train them appropriately. It's not just here you go and see you later. It's following through right to the end to make sure it's understood of what the requirements are.
Okay. Anyone else have anything to throw in? Nope. All right. Thanks a lot, Dan. We'll if anyone sends an email through, we'll obviously forward them through to you. And just a reminder to everyone that we've got Dan's details under the performance solutions section of the website. We do have Dan's details there to email him if you need help on a warm water project. Tom, are you ready to talk? You're good?
Yep, definitely.
Yep. Okay.
Okay, I'll just start my screen share. Okay.
Yeah, that's it. Cool. It's kind of off screen slightly at the moment. I'll wait to see if it. There we go. Yep, perfect.
All on?
I'll leave you to it. Yep, you're away.
Okay.
Thank you.
Thanks for having us here. I'm new to the HCAA, so I appreciate the opportunity to have a bit of a chat about our products. A bit about myself, I guess. First, my name's Tom Jagers. I work for Dux. I am the commercial technical manager. Came on board with Dux about 3.5 years ago to launch this commercial range that we've got. So, but what we'll do is a bit of a summary about what we want to go over. A few different brands in here. So how under Ritz, Dux and Therman connected. I'm going to have a real quick chat about our core range to give you a bit of perspective. Then we're going to go over the basic evolution of hot water when it comes to gas centralized plants, and then why we believe that tankless is the future when it comes to gas hot water plants. and a little bit of a touch on our fault monitoring system as well that we have coming out next year. So the first thing I'll talk about is our parent company, Neritz. So Neritz purchased Dux about 5 years ago. Probably the best thing that could have happened for Dux. It was previously owned by Caroma, which was very much focused on taps, tubs and toilets, not as much hot water. So we're now owned by Neritz, which is a very hot water focused company. Neritz is a Japanese manufacturer similar to Paloma or Renai. They've been around for about 70 years. They have they do about 6,000 units a day out of their factory in Japan, so plenty of hot water coming out of there. What's interesting with Neritz in Japan, where a lot of these units come from, is they're actually the market leader, and they've been doing commercial hot water longer than anyone else in Japan. So very well experienced company. So we're very lucky that they came on board and took over Dux. They're very big on reinvesting into the company to the point where they spend, it works out to be about $75 million a year on research and development, making sure that they've got the best products and staying ahead of the game. And yeah, they've got about 16 different manufacturing facilities around the world now. So they're selling about 2 million hot water heaters a year. So absolute powerhouse when it comes to hot water. So we're very lucky to have them. So that's how Dux fits into Neritz as well. And Thermon is one of the brands that we do our commercial hot water systems for. So basically, Dux branded commercial is through the energy management channel, whereas the Thermon branded stuff is a Reese exclusive product for any other projects commercially. So far in Australia, we've sold roughly 600 manifolded systems, and we're up to about 5,500 individual continuous flows. So that's just a quick snapshot of the company and how we're tracking. So our core range is made up of 28 litre, 32 litre and a 50 litre. Now the 28 and 32 come both internal and external. They all come in natural gas and LPG. The 28 litres a non-condensing unit, whereas our 32 and 50 are condensing units, which we're putting a lot of emphasis on these days just for the pure energy savings that condensing offers. So condensing is one of those things that is very popular elsewhere in the world. We're sort of still taking it up here a bit in Australia, and I think that's being driven more and more by rising energy costs. So I think we'll be seeing a few more of them. So when we look at the basic evolution of commercial hot water, the old way of doing things was basically boilers. Now boilers definitely still have their place in plumbing, but usually when we're looking at trying to achieve hotter temperatures around the 90 degrees or plus mark, the majority of them were type B appliances, which means you need special certification to be able to work on them or install them. That's mainly around the fact that if you get it wrong, it can be a big drama, whereas modern appliances have a lot more safety built into them. A lot of boilers are around the 70 to 80% thermal efficient. And often what you do is have a large ray pack system or boiler or any of those type of boilers out there, and you'd have to double the amount of boost there so that you had redundancy. So often a lot of these systems were quite large in size. Room vented, so drawing air from the room for combustion, quite large and hard to move about, especially when they're in a plant room or up on the roof, and majorly mechanically operated systems. Then what we moved to, or a lot of companies moved to, was a more modern approach to it, which is a continuous flow style system. Some of the advantages in this were they're type A appliances, even though the whole system can get well over 500 megajoules. It's still considered a type A appliance because each individual heater is under 500 megajoules. These sort of range from somewhere between 77 to 97% efficient, depending on whether they're condensing or non-condensing. Room sealed options, I think, are really important these days, meaning that we're drawing all the air for combustion from outside through the flue and putting all the gases outside from the room as well, which limits safety issues with ventilation in room and lack of oxygen, which we tend to see a lot of issues with, things like the doors being replaced and the vents not being replaced when the doors are replaced on plant rooms and things like that. They're electronically controlled, so they've got a much more accurate gas-air ratio, so a much cleaner burn, makes them a lot more efficient. They've also got a lot of safety sensors within them, meaning that if the air-gas ratio is out or the pressure's wrong or something like that, it's sort of normally picks it up and throws out an error code and lets it know that it needs a little bit of someone to look at it. Now, this is still quite a popular way of doing things. This is probably the most popular way I've seen in all of our projects that we've seen, just because the advantages here are mains pressure, hot water delivery, and the efficiency and modular design of a continuous flow style system. What we believe is the issue with this design is the amount of redundancy in the system. Now, we can always plan for redundancy, but there's always different levels of redundancy. And basically, redundancy is part of the system fails, the rest of the system will take over and continue to deliver hot water. But when we look at this, say your controller for your pump fails, it's not going to turn the pump on. It means you're not going to get hot water. Now, obviously, there's ways around this, but they often require manual intervention. Now, with our system, you can unplug the pump from the controller, plug it directly into the power point, and get back in hot water with a little bit of effort. But it's back in hot water until you have time to fix that control. The next thing is if your pump fails, again, there's ways around this. If the pump fails, you can have dual primary pumps. Having said that, dual primary pumps still require someone to intervene and swap over to the opposite pump. The next thing is that the tank fails. Now you'll notice with our systems is this grey pipe, bypass pipe. So if the tank fails, you can close off the valves to the tank and open up the bypass and work off the continuous flow. So there's redundancy, but there always is some level of manual intervention. Even if one of the continuous flows fails, you still have to isolate it so that there's not cold water running through it while the others are producing hot. So the next big issue that I have with tank manifold systems is the amount of pipework space and heat loss that we get from having the tank joining pipework. So what we're suggesting is moving away from tank manifold systems in the future. Now, we've done a number of these tankless systems. The probably drawback of a tankless system is you often require more continuous flows than what you would need with a storage tank to allow for those higher peaks. But there's a lot of really big advantages. So we can manifold our 28s, 32s, or 50 litres together. We can manifold up to 24 of them together. It's still a type A appliance. The modular design means that it's a lot easier to get into like plant rooms or on rooftops or anything like that. They can go and deliver water as low as 2.5 litres a minute, or we can go all the way up to 36,000 litres an hour at a 50-degree rise. They're efficient in energy usage, which I'll touch on more on the next slide. But the big thing they're efficient on is the efficiency of space. I mean, we can manifold 6 50 litres together, and they'll take up a footprint of 900 by 1.5, so quite a small space for quite a lot of hot water. These are just some of the projects here that we've done. The 28s, you can see there, up to over 1,000 litres at 50-degree rise. Couple of 32s there, and 8-pack of 50s. There's just a couple of the jobs that we've done out there in the 600 odd manifold systems. Now, the reason why we believe this is a great solution, and the reason why I think possibly it hasn't been taken up just yet in the Australian market, is the way the heaters operate with each other. Now, something that we do that not all other hot water manufacturers do, and I don't think too many do to this level at least, is have our heaters electronically connected with a cable, which allows all the heaters to talk to each other and all the heaters to work efficiently together. So things like we can rotate the first unit on every 24 hours. This means that we're not using the first unit first all the time. We're not forcing all the water through the first unit before turning the second unit on, and we're not burning out the first unit first. So that's really important for the system longevity. The other thing that is important is sharing the load across multiple units when possible. So the 50-litre continuous flow we have can get all the way up to 328 megajoules, but it can modulate all the way down to 17 megajoules. Now, there's a few advantages in modulating and sharing the load across multiple units. System longevity, of course, is a big thing, meaning that instead of working one unit at 100%, we can work a couple of units at 50%. They're not working as hard. They're going to last a lot longer. The other thing that there is a big advantage in this that some of the other systems on the market have issues with is it reduces the pressure loss through the system. Again, instead of trying to force all the hot water through one continuous flow, we can share it across multiple continuous flows, which means there's much less velocity through the pipes throughout the unit and the heat exchanger, and much less pressure loss, which reduces issues with temperature and pressure fluctuations, which is much better for a much more even hot water temperature delivery throughout the building. Probably my favorite thing about this though is the fact that when we work at a low burn, we improve our efficiency. Now, the reason for this is if you're using only a section of the burner, but still have the full heat exchange area, we've just increased our surface area to transfer more energy. And we can actually get up to about 98.1% efficient. So very high efficiencies to be had when using these systems and modulating and sharing across multiple units. No heat losses, as we said before. Now the tanks, there's heat losses, you know, you roughly use about a kilowatt of energy per 100 litres you're storing per day. We get rid of all that. No primary pumps, less plumbing and fittings. But the other big thing that is really important is seamless redundancy. So again, redundancy without manual intervention. If one of our units has a fault, it will see that it has a fault. It will close the inlet valve off to that system and continue working with the other systems in its place. So really, really important to have that seamless redundancy, especially on things like hotels, when you don't want to be having someone out there early in the morning at 3 a.m. to, you know, bypass a tank or replace a pump or bypass a controller or something. Which sort of brings me into our next point. Redundancy is one of those things that means nothing if we don't know when a heater has an issue. Now, if it just seamlessly keeps jumping to the next unit without anyone noticing, the issue with that is that you get to a point where so many units are down that you start seeing interruptions to the hot water supply. So the way around that is being able to remotely monitor our systems. So there's two ways we can do this. Our system controller, that intelligent manifold controller I was talking about before, does have outputs for BMS. So you can connect to your standard building management systems. Or we can actually go one step further and use one of our NAU to LAN systems, which connects the manifold to the internet. So the advantage in this over a standard BMS system is if any of the units fail, you get an email from Japan saying unit number 3 has failed. It might be showing, you could say, it might say something like showing error 90. You know, you have to go out there and clean the fan to get it back up and running. But you know, you don't have to race it, get out there, because you can, you know, the other units are taking over in the short term. You're not racing out there at 3 AM to fix it. You go and fix it at your own leisure, and there's no interruption to hot water supply. This is something that we're slowly launching here in Australia. We have about 25 to 30 sites that we're monitoring. Having said that, there's about 1,200 sites in Japan that we can monitor. We're going to be launching this as a fault monitoring system. Having said that, it can do a lot more than that. We can actually look at things like inlet temperatures, outlet temperatures, flow rates, gas usage. We can take this down to every 3 seconds data points and see exactly what's going on. Now in this particular slide, you can see green, red, and blue. The green, red, and blue represents the flow rate or the going through multiple units. So what we can see is every 24 hours, switching from the unit number 1, which is green, the next 24 hours we're red, and the next 24 hours we're blue. Now, this is representing basically the main unit that's running. And you can see that the second unit comes on occasionally when required, and helps out to keep up with that load. So basically it will work for 24 hours and then almost get a full 24-hour break. So really promoting system longevity with it. The other slide I want to show you is tankless energy savings. This particular project, you'll probably notice from some of the writing, is a Japanese system. This isn't one that we've got here in Australia, but we still believe the information is relevant. What we've got is the blue line and the gold line. And basically what that is showing is the energy usage over an hour, whether it's in tank mode or tankless mode. So what they did is actually run in tank mode, see how much energy it used every hour on the hour over a couple of days, and compared the averages, and then did the same again in a tankless setup. So bypass the tank, put it into recirc mode instead of tank mode, and looked at the energy savings. And what we can see is at the peak, we're using about 47% less energy in tankless mode than we are in tank mode. And that's purely things like the heat losses, being able to modulate down to get those higher efficiencies, and a number of other things as well. So that brings me to the end of my presentation. I sort of had to race it through that a little bit. I think we're right on about 20 minutes there, so on time, which is good. But I'd love to, if anyone needs to have a bit more of a chat about this, my details are on the screen. Would be more than happy to talk about our systems and what we have to offer and what we do a little bit differently. compared to what's in the market at the moment. So thank you for listening, everyone.
Thanks, Tom. So anyone, if you have any questions, you can either jump in or post them in the chat if you don't want to talk. We can ask Tom.
No question, but thanks, Tom. That was good.
Awesome. Thanks.
One thing I'll throw out there as a question was Bosch Hot Water, which I know obviously you guys aren't Bosch, but they did recently pull out of Australia, didn't they? Last year, as far as selling hot water heaters.
Yes.
Okay.
So the Bosch units were actually made by Noritz previously, the commercial units. They were about the Series 4 sort of model. We're up to about Series 8 now, so we've got a much newer model. But they, when they were no longer supplied by Noritz, seeked out another manufacturer, and I did hear a couple of issues that they had with that new manufacturer when they moved across. I think the issue was they weren't suited for Australian conditions with pressure fluctuations in water and gas supply. Yeah. So yeah.
Okay. No, thank you. Yeah, I only asked because I did wonder what happened to Bosch, and then I heard from someone that they weren't selling in Australia anymore. So that makes sense why I couldn't find a ref. Yeah.
So we're actually the next closest replacement to the Bosch system now. The condensing units line up quite well with our new Dux or Thermin commercial units. But yeah, we're the newer version of what they had to offer.
So we've got a question here from Tom. Do you have a catalog like the Ream one with flow details and generating capacities?
Sorry, say that again, sorry?
Oh, he just wants to know if you've got a catalog like the Ream catalog, which is quite detailed. They've got a big, thick catalog that they've given to consultants for years.
Definitely, yeah. So some of this information is on the Thermin website. However, if you need any information, I'm more than happy to share it. Again, if you wanted to shoot me an email, I'm happy to share that stuff across. We do have quite a large brochure that has all of our commercial range in it. But again, we tend to partner with people like Daniel at All Valves when it comes to our warm water systems and things like Apricus, who supply the solar tubes. And we've got a couple of jobs out there now where we all work together quite well. We'll have systems with, Apricus hot water tubes, solar tubes, with our hot water plant, gas boost plant, and All Valves warm water systems. So, but I'm happy to be the contact point and happy to work with the and Daniel and all that when it comes to sizing all those products. So.
And then something that popped into my mind is if we specified a Dux hot water system on a job, but the plumber wanted to use Thermin, what happens in that scenario? Because if it's the same product with a different badge on it and you have to explain to your client, like, is it as simple as that, or is it actually slightly different range that you sell under the Thermin brand?
It's the exact same product. The big difference is the way of purchasing it and who we sell it through. Now, the Dux branded commercial stuff is purely through the energy management channel, whereas everything else is. Is
that like more like embedded networks?
Yeah.
Is that you're selling it to like those companies, but not direct to plumbers?
Not direct to plumbers. So yeah, the Dux stuff is through like Origin and stuff like that. So where it comes as a package of selling hot water rather than selling a hot water plant.
So would we need to be aware of that if we're specifying units? We would want to specify Thermin rather than Dux because the plumbers are going to be buying what we specify more often than the energy networks. Is that?
Yeah. So the majority of the time, the way I've seen these projects go is they would be specified as Thermin to start with, unless the builder was to create a deal with someone in the energy management network to supply that hot water plant. And then all those energy management network channels are aware of the Thermon/Dux swap over, basically. So it means that if it does change to that sort of network, then it can be easily swapped from Thermon to Dux in that situation.
Yep. All right. Anyone else have any questions? No, we're all good. All right. Well, thanks a lot, Tom. Yeah, thanks for dialing in tonight.
Thanks very much. Appreciate the opportunity.
Okay, thank you. Howard, are you right to go?
I'm just unmuted. Can you hear me?
Yep. Yeah, I can hear you. Yep.
Start the video, and I'm going to share screen, and everything should be right. I'm on.
Yep. Yep. Perfect. We got you. All right. Thanks, Howard.
There. Okay. So we're out online at the moment. I hope so. That's great.
Yep, all good.
Okay, thank you. Okay, it's Howard Christie here from Haugen, and beside me is a gentleman named Glenn Horn, who you may not have met before, but he's in charge of and involved in Haugen liquid waste. Okay, and our presentation tonight is a little bit on grease traps, a little bit of refresher for some members who are new to the hydraulic scene, and a little bit from Glenn on what's involved in grease trap waste servicing and the waste safe system, and where we're heading. So we're going to jump through a few slides right now, and just a little bit of history of where Haugen originated from in 1996. It's an Australian-owned company, and we're a fully certified company to the global mark, and we operate 3 divisions. Haugen Proprietary Limited, which is basically all our pre-treatment products. Haugen Environmental Solutions, where we're now involving ourselves in a lot of rainwater, gross pollutant traps, brewery servicing, brewery systems, aeration systems, and of course, our new entry into the scene in the last 12 months is Haugen Liquid Waste. And basically, what we're doing is we're trying to, especially with the Haugen Liquid Waste, is we're trying to provide a end-to-end solution. We're designing the system, we manufacture the grease arresters, we assemble them, supply them, and we're now in the game of servicing them. So that's a little bit of history there. We've got 2 big factory centres, manufacturing facilities. One's in Sydney at Wetherill Park, which we moved into about 18 months ago, and our other large one is up in Brisbane in a place called Crestmead. Okay, most of our larger products, which are our rainwater tanks, anywhere from 5,000 right up to 52,000 litres, which also double up as horizontal and vertical pump stations are produced up in Brisbane, and all our other, as well as our other products, and Sydney manufacturers basically all our grease arresters up to 5,000 litre capacity, and all our different above ground, below ground grease arresters in basically MGT, MGTR and MGTS situations. And we're just about to do an exciting transformation. We're moving into from not only servicing, but we're now moving into the realms of treating the trade waste that we collect. And I'm going to let Glenn talk about that later on, but that's one of the exciting things happening at Haugen. So just a little bit of history with grease waste and situation, what you need to do. Basically, when you first start into looking at a grease trap, you need to go on to Sydney Water's website and go into the tap in section and discharge trade waste. Basically, this is the first thing you should do when you start a job. It involves letting Sydney Water know that you've got a new project coming on, what it might be, where it is, and what facilities you're going to be putting in there. Now, tonight's about grease arresters, so you basically inform that you've got a grease arrestor and the type of facility is coming from. And at that point, it registers with Sydney Water. Comes up, you get an application number, and that's where you first start the job. And from there, Sydney Water will make contact with you, and the job will progress from there. So that's the first important thing that we do. So from that tap in, basically we move on to what are the requirements for Sydney Water. I'm not too sure. I might have jumped a couple of slides there. No, a couple of slides. Okay, so this is just an extract from Sydney Water food industry pre-treatment guidelines. It's something that just highlights out of their guide for plumbing for retail food businesses. Maximum size of grease arresters in Sydney Water area, 1,000 litre to 5,000 litre grease arrestor. And all the manufacturers and suppliers of those grease arresters are listed on Sydney Water's website. Haugen is indeed one of them. And up to 5,000 litres is pre-approval. We have pre-approval up to 5,000, and also in our systems, our tanks are able to be modulated together in modular design. So in certain situations, access to premises might necessitate a door opening to get a grease arrestor through. So we have our MGT, which is 720 millimetres in width. So we can create a 3,000 litre grease arrestor inside a room with limited access by modulating two 1,500 litre grease arresters together. Okay. Next thing, kitchen waste should always gravitate to the sewer. If it's not possible, and you really got to prove this is not possible, they will let you pump to the arrestor. We all understand we can pump on the outlet of the grease arrestor, but pumping to the grease arrestor is only allowed if we cannot gravitate. Now, some people and some situations I've seen on documentations, they've had a large pump well in front of the grease arrestor. That's basically a no-no. We're trying to keep the pump station in front of the grease arrestor or upstream of the grease arrestor as small as possible so it doesn't become a default grease arrestor itself. So, you know, we look at our little models of a 300 litre pump station that Haugen produced. That's one example. Other companies have small pump stations as well. So you're looking to put a small pump station before, and in a principle in design afterwards, you're basically looking for the pump station. If you're just doing the grease arrestor itself and not running to a series pump station, the pump station servicing grease arrestor on the outlet side should be sized basically as 1/3 the capacity of the grease arrestor. Second point, grease arresters to 100 millimetre vents, induct, educt vent, obviously the main trade waste drainage stack, and also the chamber vents. They're most meant to be 100 millimetres in diameter and rise individually to termination. I know venting is a subject which is going to be talked about with different consultants and Sydney Water in the near future. And it's been one of my pet things to try and have the ability to join a number of grease arrestor vents together and rise as a single vent. Now, it's not allowable as yet, but where everybody's working at it, and Sydney Water and indeed Haugen are heading down that line. Information, minimum 1 metre unobstructed clear space above the grease arrestor. Okay, various heights of grease arresters. I'll talk about Haugen if I may. Haugen above ground grease arresters are basically 1,500, 1,550 above the floor level. 1 metre clear access above the access chamber makes a room 2.5 metres in height to where you can put a grease arrestor. Okay. All above ground grease arresters require necessitate a platform if the access to the grease arrestor is above 1.2 metres. And those platforms have to be steel. They can't be any other material such as poly, which we'd love to make them in polyethylene, but they have to be steel to a code AS 1657, and they are to be provided so that you have no more than 1.2 metres access to the grease arrestor from the platform. Okay, just a sideline here is, as consultants, we don't get involved in this too much, but it's something to check when you're out there, you're finalising a project, that all sinks and in-floor, floor waste must have bucket traps and strainers fitted, okay, to the kitchens and all food prep areas. Okay, You must also install grease arresters as close as possible to the source of the grease, and you to avoid long runs if possible by increasing drag gradients, and consider heat tracing if you've gone over length. Now, I get a number of consultants ask me about heat tracing. Now, there's no code or any stipulation anywhere or standard associated with that. So basically, that's your own discretion, understanding the environment where the pipe is located. If it's in ground, it's obviously not good for heat tracing. But if you're elevated in a cold climate, it may be considered heat tracing, but in a temperate climate such as Sydney, it has to be a long run for heat tracing to be very effective. You must also have a boundary trap on every property that has a grease arrestor, and you must have containment backflow and zone backflow at the grease arrestor hose tap. Okay, so they're simple things that come straight out of Sydney Water's grease requirements. Another little thing that comes up with grease arresters, I get this asked question many times, it's about bunding to grease arresters. Subject up back last year with Dennis Moringas from Sydney Water, and he came back with this email, and it basically says Sydney Water does not have any bunding requirements for installations of above ground grease traps. Okay, unless, there's always unless, like the ads on TV, there's always knives and forks coming if you buy this. So unless there is a floor waste that drains in the sewage system, right, at where it's installed. So if you have a floor waste adjacent to a grease trap and it's draining to the sewer, then you must have a bund. In this case,
is stormwater okay though? Is it stormwater okay? It's just floor waste that are the issue?
No, floor waste and stormwater is an issue too, because the fact, I'll just let me finish here if I may. If you've got a floor waste, you must have a bund that holds 110% of the volume of the largest vessel in the bunding. So this is not for grease arresters, so this is any other trade waste vessel that's got other products. So 110%, so 5,000, so 5,500 litres of bunding you must have available to you. Now,
should stress there that floor waste should be outside of the bund, right? The aim of this is to stop any grease from entering the sewer system.
Yeah, and yes, that's correct, right? If there's a damage to the grease arrestor. If the reason why you put a floor waste there, and this has been by default, a number of people put a floor waste because they thought, the grease transporter is going to make a mess and spill all his product onto the floor, and they've then taken that floor waste down to the next level down. If there's in a basement situation, put it in a pump and pumped it back to the grease arrestor again. The other reason why they're there is that they just thought that they put the floor waste there, put a ton dish off to the hose tap that's adjacent, and to capture the discharge from the RPZ valve, and charging the floor waste. So the situation is that they don't need the floor waste. There's no requirement for floor waste. If you put one there, you have to bund it. So the idea, gentlemen, is not to put a floor waste there. If you need to put a ton dish to the RPZ because it's adjacent to the grease arrestor, run that, put the RPZ valve at maybe 1500 high, maximum safety in design, and run the ton dish to a location external to the grease arrestor location, to another point. Now, the last thing they mention is that if there's an accident with a grease arrestor, that the client is responsible if that wastewater runs to, say, a subsoil stormwater pit in the building and then is subsequently pumped to curb or river or creek or whatever. That might answer your question. So no, you're trying to keep storm outlets away from the grease arrestor as well. Okay, so I know some consultants, some plumbers have been caught out by trade waste inspectors picking up there's a floor waste and asking them to bund it. Okay, So try and leave the floor waste out and you won't have to bund at all for a grease arrestor. Okay, above ground grease arrestor. I did have one person asked me once, how do I put a bund round an in-ground one? I said, that's very difficult. Okay, so I hope that helps people. Try and leave the floor waste out. If you do the floor waste, be prepared for a bund. Okay, just remember, above ground grease arrestors don't need to be located in any particular room. They just need to be protected from vehicular damage, and that's usually by bollards. Okay, grease arrestor pre-treatment options. Okay, greasy wastewater should be going to a grease arrestor. Those grease arrestors can be boat-shaped, modular, curved, tank-type circular tank cylinders, or filter-type arrestors. Can also be treated by dissolved air flotation or DAF units. And Sydney Water does have a supplier, and they have been installed in McDonald's, a vertical gravity separator, a VGS, but that's not often. Okay. Materials of manufacture: polyethylene, fiberglass, stainless steel, PVC, GRC or glass reinforced concrete, and precast concrete, epoxy coat. They must all, both those last two items, GRC and precast concrete, are epoxy coated internally and have to be repaired annually. Okay. Advantages of most grease arrestors today are polyethylene and fiberglass. Some stainless steel out there, but the advantages of the polyethylene are its wax-like surface and easy cleaning solutions. And if you're looking for extra costs on a building or saving money, polyethylene is lightweight as compared to anything else. So for example, a 1,000 litre grease arrestor above ground MGT weighs about 84 kilograms. Our 5,000 litre tanks are roughly around 340 kilograms. So it's a lot easier with craneage and moving them around site. Locations: in ground, external to the building, landscaped areas, loading docks, car parks, etc. Above ground within the building, loading docks, basement level car parks, dedicated grease arrestor rooms. Where they should be held: position as close as possible to the location of source of greasy waste, as close as possible to any hard stand with direct access to the grease arrestor from the tanker, and remote as possible from any supply air intakes to the building and or lift lobbies, whatever. Where they should not be located is anywhere near kitchens, food preparation or food delivery areas. Okay, that's under complete utter no-no. Grease arrestor sizing. Okay, acceptable methods. All right, we've got number of seats, fixture flow rates, and sizing from known flow rates. Okay, if we're dealing with Sydney Water has their food industry pre-treatment guidelines. And for the food industry, you will find there that they size under as a code for sizing there, and it's often based on seats and or a particular retail outlet such as McDonald's or Kentucky Fried, etc. Well, they'll have particular sizes down for those. Fixture flow rates, basically the Water Service Association guidelines for grease, fats, oils and greases is a sizing criteria, and that's basically the same, is accepted across all states, and basically local councils, New South Wales local council, regional councils, authorities base their sizing on that guide, and indeed on Sydney Water's guide as well, but they will take sizing under the WSA code. Sizing from known flow rates is also in the WSA code. Basically, that's knowing what the flow rate is, and the code gives you examples of accepting what size the clear water volume is, the solid and the grease layer, and you add the three together and that gives you the size of your grease arrestor. New South Wales commercial minimum pre-treatment sizes for grease arrestors, 1,000 litres minimum. Okay, but Sydney Water should note that they do have a note saying that the volume is only a guide. It's only a guide, guys. So I know that everybody has 5 tenancies, so they allow 5,000 litre grease arrestor. It's purely a guide. So point 3 here, I'm saying you must understand the location and the proposed use of the outlet and design it accordingly. So if I take Chatswood as an example, we obviously know that a tenancy up there is likely to be possibly an Asian type restaurant. So we should be looking at a 2K to 3K grease arrestor based on most Asian restaurants that we've undertaken studies on. So the 1,000 litre allowance is going to be way, way too small. So use those codes, have a look at sizing, not only with Sydney Water, but look at the fixture flow rates and look at the known flow rates you can pick up from the existing premises. Okay, grease trap, trucks, sizes, weights and clearances. You'll all be getting a copy of this PowerPoint presentation. So this gives you a general size of trucks that are used within the industry, just not Haugen's trucks, but other people's trucks as well. You can see that basically they, other than the small 2,000 litre grease arrestor vehicle, tanker can't get underneath a normal car park. So that's the only one. So the small ones can go down and pick up a grease arrestor contents from your basement, 1 or 2, and that's about it. Other than that, they are used for decanting, where they will run down with the small grease arrestor, come back up and then refill up a larger tanker sitting above on the roadway or loading dock area. Okay, so that trucks allows you to give those heights and things to loading docks, etc., to the structural and traffic guys. Okay, this is a question I get asked very often, and I'm just happy to say it's a very, very, very difficult situation to confirm anything. That's what's the capability of a vacuum truck. Basically, everything fluctuates here, guys. There's no rule that we can apply. There's no standard information. It all has to be based on each and every truck's capability, and they vary from transport operator to transport operator. 2,000 litre trucks don't have the suction capability of an 11,000 litre truck. Their motors and their vacuum pumps are completely different. So in all instances, you should be looking to your preferred liquid waste contractor, questioning them and getting their details of what their capabilities are for a particular job. So I stress that contact your transporter and ask their capabilities, what they've got, and what trucks are available to do their site. Taking that into consideration, there's a little matrix here that I prepared for one of our trucks, which is our 11,000 litre Haugen truck. That's a 460 cubic foot per minute vacuum capability. And this sets out the suction capabilities based on a 3.3 litre per second evacuation of the grease tank within time limits that are necessary for the transporter to make some dough, make some money. So you can see if we're basically lifting, static lift being about 4.5 metres in height, that's from the bottom of the grease arrestor to the top of the tank, we can run about 50 metres of pipework, hose or horizontal remote pump out piping. Okay. Now, of course, as the tank gets full, flow rates drop, and as the tank initially is empty, the flow rate from the grease arrestor is higher. The average worked out is 3.3. But that's just specifically to that one truck at that one flow rate. So you need to talk to everybody individually. Okay. I'm going to hand over quickly to Glenn here, and he's just going to talk about servicing and what waste safe and how it commenced in bits and pieces there. So thank you.
Yeah, so thanks. Look, I just want to give you a quick overview as to what the requirements and obligations are once the grease traps are actually installed. Sydney Water commenced the Waste Safe program back in the early 90s, simply because there was a ever increasing amount of grease balls being washed up from their ocean outlets onto Sydney beaches. So the Waste Safe program then managed the system by way of identifying frequencies and pump out conditions for each registered grease trap within the Sydney environment. Within 2 years, they had the grease balls under control and everything was working quite well. The servicing of the grease trap on the responsibility of the transporter, it's a fairly standard understanding through the industry. Removal of the lids to the grease trap, completely vacuum out all the contents of the grease trap, being the fat on the top, water in between and the solids on the bottom. They then scrape the grease trap sides down to get rid of all the buildup of the balls of fat on the walls. They flush it out with fresh water and remove all residual waste from the grease trap completely. Now, there was at one stage a requirement for the traps to be refilled with fresh water, but that is no longer a requirement by Sydney Water within the Sydney environment.
If I can just step in there, if we look at Hunter Water requires the contractor to refill with clean water.
Yeah. So I'm talking here Sydney Water, Sydney, under the WasteSafe program. Other states have followed WasteSafe, but what we're talking about here is Sydney only. WasteSafe transporters all have to be registered with Sydney Water. There are specific requirements for the vehicle to be appropriately signed and again licensed by Sydney Water. They do not need an EPA transporter license. It is not a trackable waste, the grease trap, but they must be licensed by Sydney Water. The waste treatment facilities, similarly, they are licensed by Sydney Water, but they do need an EPA license. So it's unlawful to take grease trap to an unauthorised facility within the Sydney environment. It's as simple as that. The WasteSafe program has an electronic tracking capability, and we've got some slides coming up shortly. So the transporter has the ability to identify the grease trap location, the address, the grease trap frequency and the size of the grease trap via a barcode or a QR2 code. The frequencies that are set by Sydney Water are also downloaded within the system. So a transporter is able to go into the Waste ID program, which is a subsidiary of Sydney Water, and they can identify when a trap is required to be pumped out. And obviously they generate their runs and so forth from a collective information from that detail. Following screen there is, as Howard said earlier, it's a generic kind of starting point. There are requirements where Sydney Water may overrule what you see on the screen, but that will depend on the actual restaurant or food preparation facility. So, but that's a guide for, I suppose, a consultant to be talking about as an initial starting point.
Again, basically the default is that Sydney Water will set with 13 weeks. Okay? Yeah, that's the default.
So cleaning of the grease trap, I went through that earlier for you. I mean, again, we're sending out a copy of this presentation anyhow. This is the standard that should be done by all transporters. It's not good enough for them just to go in and take the top layer off or whatever. The appropriate way or the correct way to do it in accordance with the requirements of Sydney Water is the trap must be completely emptied and scraped down and hosed down. If the transporters are not doing that, they're not complying with the Sydney Water requirement.
That's just a little advertising sign for ourselves. We thought we'd throw in.
Good to have new truck.
That's what we started about 12 months ago. So we're fully authorised liquid waste transporter. Here's a little video. We're just going to run this little video now just to give you an idea of cleaning a grease trap.
If we can get it
If we
going.
can get it going, we've just had a little bit of an issue here for some known reason. I can't pick up the, no, it's not going to work for us. No, we're having a little bit of difficulty with the video. I don't know why. Emily might be able to help me out on that. Okay, if we jump to the next slide, basically all clients enter into an agreement with whatever contractor they're using. This is just a particular copy of our Haugen liquid waste transporter agreement with a client. Basically, simple as it is, the client, the service address, the details of the trap, the frequency of the trap, the charges that are associated, and the owner signs up to it. And that basically becomes our transporter license to be able to service that client. That's again back registered with Sydney Water, that we are the transporter for that particular address. Okay.
Right, so under the current agreements with Sydney Water and WasteSafe, each restaurant or preparation place or whatever, whoever's got a grease trap must have a barcode or a QR2 code affixed to the grease trap or close by. So the blue one, as you can see, were the original ones. They're still in play. They've been in play for the last 20 odd years. We're now moving to the Waste ID or the QR2 codes. And as the driver turns up to the facility, he is able to scan either the barcode or the QR2 code in his mobile phone, and that acknowledges directly through to Sydney Water that grease trap has been serviced. Once he fulfills his job there and he's filled his truck, he'll go to a registered treatment facility. And again, the big barcode on the right-hand side, although it says waste transporter, there's one in the truck. There will also be another one at the waste facility. He will then again scan his phone onto that QR2 code, and it will download into the Sydney Water system all of the grease traps that the driver has cleaned or serviced within that day. So it's an automatic validation by the contractor and the treatment facility that the grease traps have been serviced, cleaned, and presented to a registered waste facility in acknowledgement of the Sydney Water requirement. And you want to talk on the strata?
Okay, just very simple. That slide, you can all read that later on. It's basically just to understand that a number of retail tenancies, there must be a single owner responsible for the grease arrestor. So that becomes one owner. So it's usually the owner's corporation or the master strata, and he enters into the agreement, and he then pays all the waste safe charges associated with that, and then subsequently passes on the cost to his tenant. So just remember that the master strata must complete the application or the agreement with Sydney Water. Okay.
So as we just said, with the barcode or the QR2 code, it's a requirement under Sydney Water that the transporters are licensed by them, that they do utilise the Waste ID program within the Sydney Water system. And there's 14,000 registered, or 14 to 15,000 registered grease traps within the Sydney environment. Sydney Water has about an 83 to 86 % success rate on registering them. So there are still some grease traps that are not registered with Sydney Water. We're still able to service those grease traps, and we use an independent validation code for those when we take it to a treatment facility. We're also able to affix a new QR2 code to that grease trap as a licensed contractor and register that grease trap on behalf of the restaurant and so forth into the system. So we're kind of working as an agent on behalf of Sydney Water these days, for those restaurants that are not listed. As I said earlier, within the Sydney environment, a registered grease trap must be collected by a licensed waste contractor, and it must go to a licensed treatment facility who are working similar to Sydney Water. They're working under an EPA license for treatment, as well as a Sydney Water agreement. Yep. So I think this has been discussed with you fellows before. Sydney Water are identifying that they are under some pressure at the moment by the EPA because they're getting an increase in grease build-up within the sewer lines and so forth. Couple of reasons for that.
Yeah, like, look, you know, what's been happening, and I know that Sydney Water has spoken before at our association meetings, and basically they've identified, you know, one of the biggest things is what they're calling black kitchens. In other words, home catering from residential properties, you know, and a high demand for home delivery and preparation. The other source is the fact that changing lifestyles, Generation X and Y are eating out. So basically a grease arrestor that was sized for a particular number of seats or meals and suiting a restaurant or a kitchen at one particular stage, that kitchen we might have been doing 100 meals. Suddenly they're now doing 400 or 600 meals, and hence the grease arrestor is not handling the load, and it's pushing through and going through the grease arrestor, and the grease arrestor is not being able to cope. So you know, this goes back to how we size a grease arrestor, understanding that our eating habits have changed, the food that we eat. We were originally, when these seating sized coping for grease arrestors came in with Sydney Water, it was a meat and 3 veggies type situation. Now it's you know, food from all over the world, obviously a high content of Asian food in the city, and which is a lot of oils associated with that. So the sizing criteria really needs to be looked at carefully, and that's that reason why that's here. Sydney Water, yeah, is trying to identify and deciding how they can work with all these black kitchens and along with councils and bits and pieces. But just another example, a small cafe or a grease arrestor was put in at Eastern Creek, looking to service, you know, possibly 150 meals. So it was a 2,000 litre grease arrestor put in. Its operation changed to a catering kitchen, operating from 4 in the morning till about 11 o'clock at night, producing about 4,000 meals. The grease arrestor discharged from the outlet of the grease arrestor was found to be at 58 degrees C, and grease was just running straight through the system. So you've got to be very careful looking at the facilities, how they're going to be used, when they're going to be used, and understanding that, you know, the change of use, or going from just a cafe and producing meals for the local industrial area to coming into a catering kitchen. You know, Glenn's picked on this, talked about this a little bit before. So if Sydney Water, and we look to sort of increase the frequency of servicing, you know, the industry as such in the transport industry may not be able to cope with the increased service requirement. They may not have enough fleet to cover that situation. The EPA licenses at the waste treatment depots may not be able to license to cope with the increased volumes. The fact there'd be high discharges of Sydney Water resulting in higher costs, but of course those be passed on to the client, so that's not much of a problem. But you know, increasing the frequency is not really doesn't solve it. It's looking at the size of the grease arrestor and allowing for a larger grease arrestor than what is currently out there, you know, to make the system work. Yeah. Noise and odours, okay, self-explanatory on this one. We've got to comply with noise codes and obviously and odours from grease areas. When we're cleaning it as a transport operator, we're fully aware, but that basically comes back to the consultant and where the thing was, you know, placed in the first instance.
Yeah, the grease trap contractors normally operate from early hours of the morning through till, you know, early afternoon. So anything that poses a potential odour or noise issue, are normally done outside normal trading hours, so that there's no interruption. It's a difficult environment to work in most cases, but it is taken into consideration by the contractors.
Okay, just this one. As consultants, we sometimes get phone calls back from clients, saying the grease arrestor system is not working, the grease arrestor is not working, it's surcharging, or some problems associated with the grease arrestor, odours and bits and pieces. And we're asked to explain why. Well, often the first case is we go back to the housekeeping of the tenant, the owner of the agreement, the owner of the grease arrestor, if their housekeeping is up to scratch. Are they keeping the oil in separate drums and taking it away by dedicated waste transporter and not pouring it down the traps to sinks or floorways? Are they using a cleaning detergent or a brake detergent that in excess of the particular allowance for the emulsifier to break down and drop out the oil within the time it's held within the suspension in the grease arrestor? And that's made up by dilution scales, ratios, that they're not completing using the fluid directly without mixing it first. So emulsification in the grease arrestor is another problem from cleaning of the grease arrestor. So basically goes back to housekeeping. That's where the first thing you should check, are they doing the housekeeping? And that includes for the transporters as well, making sure that the grease arrestor is accessible, gates are open, trap lids are able to be removed. It's not the transporter's responsibility to make sure that a grease arrestor trap can be lifted. So that's all back on the client. It's responsible that their barcodes are all there and visual at all time and haven't been removed. So housekeeping is very important from the generator. Confined spaces and bits and pieces, grease arrestor rooms. I've just thrown this one in because sometimes it does come into question. Basically, a grease arrestor room with a full safe access egress situation, in other words, be able to walk in and walk out, is not considered a confirmed space. It is considered a place of work. Okay. If you have to enter a hatch in any way to get into any room or descend down into a grease arrestor chamber, a grease arrestor tank of any sort, that is decided to be a confirmed space and should be treated accordingly. Okay, so grease arrestor chamber rooms are not a confined space if there's full height access and egress and lighting, etc. Okay, and last of all, we'd just like to say that Haugen has been involved in grease waste for over 25 years, and we are happy to say that we will now becoming an end-to-end servicer. So what we mean is we're going to design grease arrestor, manufacture and supply service, and we are going to treat in the near future all our own grease waste from our own transporters. So basically, we will be providing an end-to-end solution for all our customers. We're just about to start construction of our new treatment facility at Wetherill Park, which will be a state-of-the-art facility and will meet all compliances with Sydney Water Waste Safe and EPA requirements. So offering you an end-to-end solution. And just as a sideline, that all our products are warranted for 7 years, but if we get a contract where we supply and service a grease arrestor, our warranties will increase to 10 years at that time. So that's something to think about, and an opportunity to involve Haugen in the supply of the grease arrestor and the servicing of such. Basically, that's about it. It was pretty pushed, a bit over time. So are there any quick questions out there?
Okay, Howard, it's Rod Ware. Look, I've got a couple that I want to quiz you on. So the pump upstream of a grease arrestor, have you seen any of those installed?
Yes, we have installed those. We do often supply our little Haugen units, a 300 litre pump station with single or dual pumps in it with a level transducer. So we're keeping away any floats or any of that floats within the tank. Basically in-out situation, Rod.
Yeah,
We're
okay.
trying to hold any water any wastewater generated from the kitchen facility in that pump station, and they're supplied with vortex pumps. So that's just pumped from there to the grease arrestor. Okay, so as small as possible. Obviously, we use our 300. Other manufacturers, the pump stations have, small 500, 900. But the idea is to keep it, well, as small as possible. So just basically in-out situation, right?
Yeah. Yeah. Okay. No, that makes sense. I mean,
that doesn't become
imagine that. Well, I would have thought they'd still block up over time and require a bit of maintenance or a wash down or something. But
yeah, look, facility management, with that situation would have a routine maintenance. Would be checking on those, and that's something good facility management would look after.
Yeah. Just another point you said there, grease arresters don't necessarily have to be in a room if they're internal.
No, grease arresters are no longer required to be in a room, and that's basically been the situation since we've had sealed tops. Okay, all of those grease arresters need to be sealed, and as such, they no longer need to be in an actual.
But to say that's in a basement car park, what happens when you take the sealed lid off to wash it out? The whole car park stinks.
A correctly functioning grease arrestor shouldn't have a huge pungent odour, but we do know that they all have an odour.
Yeah, I was going to say, I haven't seen one of them yet.
Perfectly performing grease arrestor, that the odour shouldn't be as much. It's basically a 30-minute to 45-minute process associated with cleaning and tidying up and checking the grease arrestor from end to end situation. If you feel like there's an opportunity for that to be distasteful to the clients or the residents of the complex, if it's an apartment block with retail underneath, and if it's a retail area, it's usually done out of hours. The smell dissipates through the exhaust system in the car park. But if it's again that can enter into the building through lift lobbies or any other sort of methodology, well, there's still the opportunity for you to put it into a room. And
look, I think we'll continue to do that for our clients and make sure that room's mechanically ventilated.
To do that, Rod. But if it's not out there, it does need to be protected by bollards.
Yeah. And look, just one other one is more of a comment than a question, probably for any other consultants listening. Just be careful when you're looking at particularly like a mixed-use development, and you might have a whole bunch of retail on the ground floor or a podium or something. We got caught recently on a job where we'd based our sizing on the number of seats of each tenancy, and it wasn't till quite close to the end of construction where they added all the outdoor seating, which we hadn't allowed for. And that stuff wasn't on the drawings for a long time, certainly well after they'd started building the development. And then when it got time to putting tenants in there and Sydney Water started asking questions, they were underdone in terms of capacity. So just if there is a substantial outdoor space, just add probably 20 or 30% to whatever your tenancy is so that you don't get stung by that.
Yeah, the basic starting procedure that is out there that I've always operated on is 2 people per square metre. That gives you certainly some extra volume to look at when you've got a tenancy that you take. Basically, let's wipe out a third for the kitchen back of house area in a tenancy, and the rest is provided for seating. Take that square metre, multiply it by 2, that gives you a seating arrangement. But as Rod has indicated, basically outdoor dining is the name of the game now, and you should allow for that. But the biggest thing is that as soon as you have an Asian Pacific sort of situation, tenant moving in and utilising a wok, you're straight up to a single wok, wet wok outlet is a 1,500 litre grease arrestor straight up. most wok units coming into an Asian restaurant are what they call a double wok unit. So, you know, you're moving straight up with the other fixtures involved, you know, sinks, etc. You're basically looking at a 2,000 litre. My latest job was going out looking at a tenancy at in Green Square, six retail outlets. The whole job was approved with a 6,000 litre modular grease arrestor system in that building based on 1,000 litres per tenancy. There's 3 Asian restaurants operating out there. Those individual on the WSA or WASA sizing guide on fixtures range from 2,700 litres grease arrestor requirement for one tenancy, one at 2,600, the other one at 3,200. All of them had 6 wok burners available to them and have utilised them at peak times. So 6,000 litre grease arrestor system needed to be 12,000 litres.
But correct me if I'm wrong, I don't think Sydney Water's policy for retail food doesn't stipulate that wok requirement, does it?
No, it doesn't have any fixture unit allow. Sydney Water does not use the fixture unit system at all.
Yeah.
But basically most other states do. Local regional councils in New South Wales accept the WASA coding along with Sydney Water. Some will relate back to Sydney Water's requirements, but most other states are based on fixtures where possible. If they haven't got that, they will upsize the grease arrestor. But they all have 1,000 litres minimum, but they will come back and ask you what the function in, say, Queensland, they'll ask you the function of the restaurant, and then they will give you the size accordingly. You can't do your fixtures if you haven't got a floor plan. If you've got a blank retail space, that's where you've got to use your best assumption as to the location of that, you know, retail outlet. As again, Chatswood, you know, different areas, you know, Cabramatta, you know, there's going to be Vietnamese and bits and pieces out there. This is not being, you know, this is just population groups in areas. You know, the type of restaurant that's going to go in there in the kitchen, and you need to size it accordingly. 1,000 litres is just not enough. You know?
Yeah. Okay, thanks for that.
Thanks, Rod.
Thanks, Rod. Tom's put a question in about the ventilation requirements from AS 1668. Do you know anything about those?
Okay, look, 1668 ventilation code. I have trouble being a hydraulic consultant, let alone mechanical engineer, Tom, but I think it states roughly for a grease arrestor room, it was basically 5 litres per second per square metre of floor area. Okay, it's the floor area of the room, not the grease arrestor surface area. So that's basically, if you look at a 20 square metre room, you've got 100 litres per second airflow being extracted from that room. That's as far as I've got expertise on 1668. Obviously, then you can have interlacers on the fan where if the door is open, because it's negative pressure, if you open the door, the fan can accelerate and increase the flow rate in the room because the door's been opened. But that's where it sits at the moment. So mechanical engineer would have to answer you there. But as I mentioned earlier, venting, Sydney Water is basically, you know, with a 5,000 litre limit, is now a lot of establishments coming up where we have 4 or 5,000 litre grease arrestors installed. And as such, each one needs a chamber vent and each one needs to be extended to termination point separately. Well, separately than in connection with a sanitary plumbing stack, but nowhere in AS35 standard does it say that they can't be interconnected with each other at this stage. But there is no criteria for interconnecting the vents, and such as in the sanitary plumbing having a header vent system. So we are looking, along with that, a number of consultant companies that's talking to Sydney Water, indeed as Haugen and myself, and we are looking at how we can combine a vent suitable to run a single vent through up 20 stories or 40 stories through a building to termination instead of running 5 vents up individually all the way. Now, since ventilators have become sealed, basically we're looking at the production of methane from the rotting solids and food materials within the arrestor And that methane is what is actually going up through the vent system, both the induct and the educt vent. Basically, a 20-story vent is not producing any cooling effect to the grease arrestor. That was one of the ideas of an open top grease arrestor in the grease chamber room, that the air circulation across the top would help cool the contents and aid the function of the grease arrestor. Now that all above ground grease arrestors are sealed and must be sealed, there's basically no air transfer occurs between through the grease arrestor from a 20-story induct or educt vent. Basically, the induct vent, it really is only acting as an anti-siphon vent in case of suction occurring to the grease arrestor on the outlet and stopping the grease arrestor contents being sucked out. There's no air transfer assisting the grease arrestor cooling. And the only thing that's going up and down the vents is the production of methane, methane being lighter than air, and that pressurized within the grease arrestor chamber, because it's sealed, pressurizes to the point where it will rise up through both vents into the duct vent. So myself and some other consultants, and Sydney Water has been very aware of this, we're trying to work out something to enable the calculation of what's necessary in a combination of grease arrestor vent and joining a number of grease arrestor vents together. So that's work in progress. And as soon as we come to a resolution on that, Sydney Water, we'll make note of that to the association. So I hope that answers Tom's question.
Tom's thrown another one in. Do you think grease arresters should be fitted with reflux valves on the outlet to stop sewer overflow entering the grease arrestor? I was going to raise that one as well, because Port Macquarie Council require reflux valves on the outlet. So I was going to see if you guys had an opinion on that.
Basically, AS 3500, I think you'll find that water requires the situation. If first up, we have a surcharge gully. If the grease arrestor is above the level of the surcharge gully for the property, there's no requirement that states that you have to put a reflux valve on it. If the grease arrestor is located and such that the surcharge gully it's below the level and that the pipe can actually be subject to surcharge, then a reflux valve should be installed. Look, safety in design, you can say put a reflux valve on it, because if there's found to be any black water back into the grease arrestor, the transporters won't take it and the waste stations won't accept it, okay, as greasy waste. So as soon as surcharge happens back into the grease arrestor, there's a problem. We all know that blockages can occur anywhere in a line. So on the outlet or downstream of the grease arrestor, we can have stacks and other sanitary fixtures joining into that pipe. If there's a blockage occurred, well, it certainly can go back to the grease arrestor. Look, as a safety precaution, if the above ground situations, certainly a reflux valve can be installed and maintained regularly, but they do fail as well. But to Tom and yourself, sometimes it's mandatory, as you just said, Nick, but other not mandatory. We have no statement on that at all.
Okay.
Take or transport black water.
A couple of other quick questions. So you were talking about a bund earlier. Is there a specification on the bund height? Is it meant to be the capacity of the grease arrestor can be held in the bund, or is it just a 100 mil hob, or what's the?
It's 110% of the capacity of the vessel that's containing the trade waste. So 5,000 litre vessel, 5,500 bund capability.
Yep. Okay.
Now, when you'd have the bund, Nick, you've just got to also come back into play. You have to look at the step over into that bunded area. Righto, and you've got to make sure that you can access and egress that bunded area safely. Now, I'm not an expert on that, but that becomes back to possibly steps in and out, and necessitate a landing or ramp to get in and out of the bund. So that's where you have to talk to the architect to make sure it's accommodated for that. So if you had a bund that had to be 100 millimetres high, such as a brick wall, then you can't step over that safely. So you'd need a ramp up to it and landing and a ramp back down into your grease arrestor room.
And you're also not allowed to have any valve or pipe working going through the bund. It has to be up and over.
Yep.
So the bund has got to be completely sealed.
Okay. Now, Howard, you worked as a hydraulic consultant for many years, didn't you? Just for everyone else's benefit here that doesn't know you.
Yeah.
Yep. So if people do have technical questions, Howard's come from the same background, so he's good to talk to about issues. But the best technical contact, is that you, Howard, or should we be talking to someone else at Haugen when we call?
Technical stuff with design, certainly myself. Certainly anything to do with liquid waste transport and treat that side of things. You speak to Glenn, but basically I'm here as the hydraulic consultant representative. So all calls can come through to me, and I will put the appropriate person on to look after anything there. So if you're looking for agreements or waste contracting work or recommending a liquid waste, Haugen as a liquid waste contractor, transporter, I'll get one of our my colleagues here who's in that department to contact you directly. So yeah,
Okay.
I'm the first point of call for any hydraulic consultant. That's correct.
Yep. Excellent. Thanks, Howard. And then, so with your truck limitations, you said we would have to get specific advice for the area that's being serviced. But if the truck changed in that area, is it just a matter of if we had a grease arrestor that was a little bit deeper or lower down than somewhere else, that they'd have to order a specific truck from you guys and say this is a long distance suction line, and you send a specific truck?
There's a number of grease waste operators or transporters, Nick.
Yep. And
they each have different sized trucks, and each different sized truck will possibly have a different vacuum pump capability on it, right? Cubic foot per minute vacuum situation. Now, and the power of that and the time that motor can evacuate the tanker to create the vacuum. So, and accordingly, the small vacuum pump doesn't have the same capabilities as a 250 CFM vacuum pump situation as against a 460 or an 800 litre CFM vacuum situation. The lift capability and the time taken to evacuate the grease arrestor is metrically progression, right? So what we're looking at is the time it takes to take out the grease. If we create a vacuum, once we can do the static lift, a vacuum will continue to evacuate, but the flow rate and the velocity of the evacuation is so low that it becomes unworkable, right? So the contractor could be there all day, creating vacuum, then system falling over, then having to create vacuum again because the size of the vane pump or the oil ring vane pump can't keep up with can't keep the vacuum. So
where does this become relevant to us in our designs, though, is what I'm getting at. Like, there's lots of different trucks, but
you have a basement car. Sorry.
The best way to understand it is a fully functioning vacuum pump, regardless of the CFM, theoretically will lift about 27 feet vertical.
That's the
so that slide that you had up earlier, if we send that to our members, they can use that as a good design guide for whether or not their design is suitable for a truck. Or
Nick, no, unfortunately, I've done an exhaustive work trying to come up with a matrix that can be utilized as a generalization. There is not one. I can only say for a particular truck, this is what we can do. Now, let's say, for example, the large 11,000, 12,000 litre trucks by all operators carry anywhere up to 60 metres of flexible hose on them. Okay, the small 2,000 litre trucks have got up to maybe 30 metres of hose, if that. Okay, the little ones often go down into a building, into the basement, and they're parked at the same level as the grease arrestor sitting above the floor. So there's basically, the static head is only generated, as a metre and a half, but that's the lift. So they're quite able to evacuate the grease arrestor in the minimum, in a reasonable amount of time.
So if we pinpoint this to a safe guide for consultants, we could say a 5 litre vertical lift, 30 metre horizontal, and anything outside of that, we talk to you guys, or what's a line in the sand that we can draw to say, look, anything.
So what I'm trying to say to you is that if we had, we need to have a reasonable time of evacuation, right? Otherwise, as I said, the contractor could be, waste contractor being there all day. So reasonable quality of time for a 5,000 litre evacuation is 3.3 litres per second. I can generate a system curve that can tell me that I can, if I'm looking at a flow rate of 3.3 litres per second, I'm going to need the residual vacuum, after static lift for the pump. I've got a system curve that will tell me I need about 1.13, 1.13 residual head on the vacuum. In other words, a head on the pipe work of about 1.13 litres, or just normal pump head, if you like. So you can relate vacuum pump back to a normal pump. So with 1.13 litres on a certain length of pipe, I can push 3.3 litres per second through it. Okay.
All right.
Now,
Now
when I first start off, if I might have more head, I might be able to pull 5 litres per second out of the system. As the head diminishes or the tanker fills up, I have less head available, so my suction becomes slower. Now, if I have trouble lifting a static head, righto? Now, the static head for maximum vacuum lift is about 9 metres, actually 9.3, righto? But that's for clear water, no solids, no grease, no oils. There's basically necessitates about a 30% deduction because there's no specific gravity that can be applied to greasy waste because it changes all the time. So 30% deduction on that. So we're looking at a maximum lift of about 6.5 metres with a static lift. That's a fully laden hose of 3-inch diameter full of sewage, grease waste. Okay. Now, anything above that, we might be able to pull a little bit more, but we have to then apply an air induction, pipe back onto the hose to induce air into the pipe, so that the weight of the liquid, or the weight of the greasy waste is reduced, so we're not lifting as much weight, and we can then suck a little bit higher. So that an operator can come along, notice that your grease arrestor is so deep that he might have a facility to be able to pump that out. Not every operator has that facility. Okay, so it's very hard to say. Am I still online?
Yeah, you're still online. Yep.
So every job is different. I just can't say. So
yeah, that's right.
Okay.
So the last.
That's what we can do with that one truck now. I've also got engaged, Bostrom up in Queensland, who produce a lot of the trucks. They're actually going to be doing some physical tests with standard trucks and standard hoses with different size motors to come back with some sort of standard. But as a vacuum system, the variables are so great that there's no particular standard that we can recommend. I can't say you can do this, do that, do this. You can lift 6 metres and go 100 metres. The one matrix I put there was for our truck based on what we could do at that static head. So that's available just as an option to look at, but please ask us individually or ask any other operator to say what their trucks can do.
Okay. So the last question was, you had your service agreement. Is that dollars per litre of grease removal, or is it a flat rate for a specific size grease ref? So how does not that we get involved with that, but just as a general question?
Look, industry standard is they will charge a number of cents per litre, which is inclusive of transport and treatment.
Okay. All right. Now, if you guys do, how long does the video go for?
3 minutes.
3 minutes, because probably the best way to do it is just get out of that PowerPoint and then just open it and share your screen again.
Get out of it. Right, leave. Okay, just trying to. There you go. Just go back up again.
Yeah, and if you got it playing there, then you can just take control of my screen again, and you can play it that way.
I just can't get my. Just hang on. I can't get. I've lost control of the mouse and everything here, Nick, so I'm just in a situation where I can't get the
It's all right.
computer back.
So while you guys are trying to sort that, so next week there is face-to-face meeting in Adelaide, which is good news for people that are getting sick of Zoom meetings and online meetings. And then we will be going back to face-to-face. We've got the Curability Club booked in for March next year. Yeah, so I think the borders are all open, so if you want to go to Adelaide next week, you're welcome to fly over to go to the Adelaide meeting. Otherwise, yeah, wait for March. And then how you going there, Howard?
We're back again a little bit, I think. Yeah. How's that? Is that coming through now?
Yeah, you just have to do the share screen thing. Can you see your button that says share screen? I'll stop sharing mine.
Aspects of wastewater treatment and is committed to providing safe and consistent procedural information for the maintenance of our products. We are the only company.
Just wait a sec. Just wait a sec.
that
Sorry, mate. We're having
end-to-end solutions.
Can you hear or see that at all?
I can hear it. I just can't see it. Yeah, you just got to click the share screen button again at the bottom of the Zoom window.
Firm sizing, access, and also the condition of the grease trap.
Can't get it.
Once the site inspection is completed, there is
At the bottom of the screen, a little tab should pop up, and then it will. Actually, Alt S. It says Alt S. If you press that, it should share it. So press Alt on your keyboard, and then the letter S.
Access to the unit.
There we go. Yep, we got it now.
Step 2. Insert the vacuum hose into the 100mm surge control device servicing pipe in the downstream MGT unit and turn the vacuum pump on for 5 seconds. Helgen Liquid Waste 3 specialises in all aspects of the upstream to providing safe and consistent procedural information for the maintenance of waste from the unit. We are the only company the kitchen taps may be turned on to flush out from on-site cleaning process, plus servicing and pump outs. Our maintenance program begins with a routine site inspection to confirm sizing, once the unit has been sufficiently cleaned of the grease trap. Insert the vacuum hose into the access lid and remove any residual liquid waste. Once the pipe inspection is complete, repeat step 3 and step 4 in the remaining grease traps working downstream. When you're ready for the final cleaning of the grease trap, simply remove the designated hose tap and connect the hose. The surge control device, or SCD, can now be hosed down. The SCD can also be backflushed by inserting the hose down the outlet inspection opening or the internal service. This will clean the inside of the SCD. Step 5. Once cleaning is complete, a visual check of the SCD inside the unit and surrounds is completed to ensure all is secure. Step 6. Finally, replace the
Maybe you can just send us a link. I'll stick it on the LinkedIn forum. If you send me a link to your YouTube video.
I've got you. I just don't know why it's not coming through.
Well, it's working. It was just playing 2 videos at once, so we could see the video, but we just hear 2 videos at different time sequences.
Oh, righto.
Yeah. So that was we got the intention. Like we saw the bulk of the video, so we'll just stick the link on the YouTube, the LinkedIn forum, and then people can watch it when they're ready.
Okay. We still online with everybody, Nick?
Yep. Yep, we're still online. Yep.
All right.
Yep.
So that's it from us. So happy to take questions on the phone or email.
Yep.
And we'll go from there, and we'll send that video out. Thanks.
Excellent. Mate. Okay. Thanks, Howard.
Good night.
Good night. Okay. So, So the Canberra meeting we did postpone from 2 weeks away to next year, and then we're hoping to have the Canberra meeting face to face at the Novotel in Canberra. So thanks everyone for tuning in tonight, and we'll see you next year.
All right, thanks, Nick.
Thank you.
Thanks, everyone. See you later.